better. So I will do quite a long explanation here. Because otherwise we will lose the First of all, yes? Where are the animals situated? Question 1.
On the rocks.
On the rocks. More or less, yes. Where are the seaweed more or less situated? More or less in the water and farther near shore. So the first big important thing you have to remember here, we have two communities. We have an exposed community, so organisms that are less tolerant to desiccation and less tolerant to strong wave action. And those are really the bigger organisms and the soft-bodied organisms, such as and the seaweed species. While on the rocks, so the ones that are really exposed to wave action and the ones that are really often exposed to air, there we find mainly an animal-based community. And all these animals have been adapted to one way or another to really expose a strong wave action. For example, the mussel, you probably recognize the mussel. This is a mollusk and it has a foot, and the foot produces threads, abyssal threads. That's one that uses it to attach itself to the shores. This one, anybody have an idea what this is? A limpet, common limpet. The Latin name is patella. And what does a patella in English in Latin mean? In a human body. It also exists in the human body, a patella. It's a kneecap. It's named after the shape of your kneecap, this species. Now this is a mollusk. And you see, just as a mussel, it also has a foot. And you can really see here, the foot has really evolved quite big, central disc shape, and it will use itself to suck itself to the rocks to make sure it stays attached and it doesn't get swept away by the tidal action. That's a limpet. There are some organisms growing on here. What are those? Barnacles, really good. Are these also mollusks? Yes? Everybody agrees? Yeah? No. Wrong, I'm sorry. This is not a mollusk, even though superficially it looks like it, but it is not a soft-bodied organism, and it doesn't have a foot, so it can't be a mollusk. This is a crustacean. And so it starts its life as plankton. It swims in the water, and it will settle down on the rocky shores, and it will start shaping it or making it a shell to protect itself. But in the end, when it's submerged in water, it will open it. You can see the opening here. As it passes, you will see there is a small mouth, although it's not a mouth. It's just an opening where the organism will come out with its tentacles and will then start collecting particles in your water. It's a filter feed. Okay, then we have some other mollusks. Can you maybe get them out of all the mollusks that we still have collected?
The blue.
This one. Yeah, that one here is important. You have some more, I see.
I think so. We have different colors also.
Yes, this is a really important one. And I think you have another species as well there. I know it's here, the big one here. This one? No, this is the mussel, we don't need it. This one. What are these? And these are snails. We have 6 different species here. 3 types of periwinkles. Littorina. By the way, for the aquaculturists, this one is sometimes cultivated, especially in France. It's edible.
Oh, I lost one. The most important one actually for my story.
Anyway, there are 3 types of periwinkles. And they also have a zonation pattern. Why is that? Why can't they coexist together? Yeah, they have to evolve it. Because of the principle of Gauss, the competition exclusive principle. Organisms of the same niche can't coexist together, so then you have to divide your niche into smaller subniches. This is an example of that. During the excursion videos, you will see some more examples of that with birds, also with seaweed and barnacles as well. We'll come back later. Anyway, that's Littorina. This one is another species but this one here is a really important story. It's actually an amazing story. Those 2 snails you saw earlier are vegetarians. They eat seaweed and diatoms. You will also find diatoms in the tidal This one is a carnivore. It's a carnivorous snail. And it was almost extinct. Okay, maybe because of some conservation efforts, but I will talk about it later. What does a snail do? It will feed on other mollusks. It will drill a hole in the shell of the mollusk, such as a limpet or a mussel. It will suck out some digestive fluids, some enzymes that digest it, and then they will suck it up. And then they will move on to the next one. This one was really sensitive to tributyltin. Tributyltin. It's a compound that was used as an antifoulant. So they used to put it on ships and other structures to make sure that there is no fouling by weeds, so that that not other organisms, like for example the barnacles that we talked about, or seaweed could grow on it. These are what we call fouling organisms. So organisms that grow on other structures. These barnacles are epizoans. That means epi, on the surface of zoans, other animals. Although they anyway, back to the story. So against anti-fouling, you need some compounds. In the past, it was, for example, used a lot of copper. Copper is also really toxic for fouling organisms. So that's really, we are really sensitive to that as well. So then they switched to tributyltin, and they thought, oh, this is a miracle. Chemical, no fouling, stays long, it's persistent. So we thought it's good, quite good. Probably have heard this in the class. Because this species, the Nucella, the purple snail, actually what was the consequence of the tributyltin exposure, the females developed a penis, not a functioning one, but a morphological similar one. There was no copulation possible anymore, so your population goes extinct, and this is why it's really was almost extinct here. It didn't occur here anymore, but since tributyltin has been banned, concentrations are decreasing, and this species is occurring here again. And you will find some pools where they found their eggs. If you start looking at tidal pools, you will find clutches of these eggs, of this species. Really cool. So the one who found this, and you will find there are actually quite some different color variants. You can find them in dark brown, in red, bright purple, and so on. And often you can see it here, but this one is, I think, it's dead. I don't know, almost died. Here you can see this is also purple snail. It looks a bit different, but here you can see the purple sheen. Exactly. And you will find even bright purple ones. You can find them in all shapes and sizes, and with all types of color variants. It's really cool. Okay, we've been talking about animals now. There was one, maybe you found it, have you found anemones?
Yeah.
The anemone is the one exception. It's really sensitive to desiccation and to tidal action. So you will find it mainly in the submerged part, the subtidal area.
There's one.
Exactly. So what do you notice now? It's just one blob. But was it the same when it grows in the water? This is one is the same. The tentacles, exactly. Because it's like this barnacles we found, it will also have tentacles to catch particles that are floating in the water. Exactly, that's the same sort of thing. That's the exception. All the other organisms, animals, are more in the exposed parts of the rocky shores. Now, there is also a zonation going on. If you look here, you will find mainly more mussels. If you go up, you'll find less and less mussels. And this has to do with their tolerance to desiccation. Mussels can't go too low, because if they do, they are available to their predators, starfish. So they are limited to going more in the subtidal area. They can't feed all the time, but at least they stay alive, and they are submerged long enough to feed. It's the same with the barnacles, but the barnacles are weak competitors compared to mussels. They're smaller, they started their life as planktonic, so they have to settle, it takes them a while. So what happens is, the mussels, where possible, in the best areas you see here, they grow in clutches. Either your barnacles can grow on your other organisms, or they were more restricted to more near shore, more to the coastal areas, more in the higher parts of the eutidal to the mid-tidal area. So you see competition and predation influence where they are growing.
One question, what they aggregate just in some parts and not in others?
But they like to tend to grow together for protection against predators. That's why. And also you see they are also restricted to like the holes in your cave, because those are the parts that are being submerged fast. So they get as soon as possible the water they have. You can see that clearly. and those mussels can actually move. So, unlike the barnacles, they sit for life. These mussels, if they don't like it, they will use their foot, the vessel threads, and start moving away until they have the location they want. This is why they're stronger competitors, because the barnacles are set for life. Once they settle still, mussels can still change. Okay, enough of the animals. We will now start talking about the plant-based species, although I can't say plants because they're technically not plants. Where do we find those? In the less exposed areas, more sheltered areas. Okay? I will come back to you in a minute. Anyway, what I want you to do now is to start looking at where do the different seaweed species, the different colors occur. I will discuss this later. I will now go to the other groups because I need to give attention to everybody. Okay?
Okay. Thank you.
Yeah, perfect. Keep it with you because there are several crab species here in which I also have interesting stories to tell. Good luck, guys. You did a good job already. This is a remainder of some brown